Hello everyone, in this video I'm going to teach you about the latitude and departure of a line, how they can be calculated and how the coordinates of forward point can be calculated if the coordinate of the backward point, length of the line and bearing of the line is given to us. And at the end, example related to that will be solved. Now let's discuss about the latitude and departure of a line. We know the standard direction north, east, west, south. Now let's show these direction in 3 dimension. Now northeast quadrant, if we have a line AB which is inclined to certain angle. Now if we apply some light from this way, so a projection will be formed on north-south axis. Similarly, if we apply the light from the top, a projection will be formed on east-west axis. So the projection that is being formed on east-west axis is called departure, which is defined as an orthographic projection of a line on east-west axis. Similarly, the orthographic projection of a line that is being formed on north-south axis is called latitude. Now let's show the departure and latitude in 2 dimensions. The green line shows the departure and this light blue line is the latitude. Let's say that the length of the line is L and bearing of the line is theta. The green line that shows the departure at the bottom can also be taken to the top. Now we have a right angle triangle. Now let's discuss how we can calculate the departure of a latitude of a line if the length and bearing of the line is given to us by considering the trigonometric ratios. By considering the sine theta, which is equal to the perpendicular upon hypotenuse. In this case, perpendicular is departure and hypotenuse is length. So then sine theta would be equal to departure over length of the line. By cross multiplying, then the departure would be equal to L sine theta. So if we know the length of the line and bearing of the line, then we can calculate the departure of a line. Similarly, considering another trigonometric ratio cos theta, which is equal to the base upon hypotenuse. In this case, base is latitude and the hypotenuse is L. So cos theta would be equal to latitude over L. By cross multiplying, then the latitude would be equal to L cos theta. Similarly, latitude can also be calculated if the length and bearing of the line is given to us. Now let's discuss how we can calculate the coordinate of the forward point if the coordinate of the backward point is given. Let's say in our case the coordinate of A point is given and we are being asked to calculate the coordinate of the forward point. In this case 0, 0 is the coordinate of A. So the coordinate of forward point can simply be calculated by adding the departure and the latitude. The first digit shows the value for the horizontal axis and for that we have departure, and the second digit shows the value for the vertical distance. In this case it is latitude. So in first digit the departure would be added, in the latter digit the latitude would be added. So we have the formula for the departure as L sine theta and the formula for the latitude is L cos theta. So simply there would be addition of that. Now instead of 0, 0, if we would have 50, 100 as the coordinate of point A, similarly 50 and 100 would be added with departure and latitude. This is how the calculation for the coordinate of a forward point can be calculated if we know the coordinate of the backward point, the length of the line and bearing of the line by simply calculating the latitude and departure. Now let's discuss how the latitude and departure of a line can vary in different quadrants. Likewise, if the line lies in this quadrant, the northeast quadrant, in which the bearing will vary from 0 to 90 degree, in this quadrant both the latitude and departure would be positive. Similarly, if the line lies in southeast quadrant, then in that case the bearing will vary from 91 degree to 180 degree. Then in that case the departure would be positive, however the latitude would be negative. Latitude is negative because we are moving vertically downward. In previous case we were moving vertically upward and also horizontally rightward, that's why both was positive. But in this case we are moving rightward, that's why the departure is positive, but downward, that's why the latitude is negative. Similarly, if the line lies in southwest quadrant, then in that case the bearing would be from 181 degree to 270 degree And in that case, both latitude and departure will be negative because we are moving leftward and downward. And if the line lies in northwest quadrant, in which the bearing can vary from 271 degree to 360 degree, then in that case we are moving leftward, hence departure negative, but we are moving upward, therefore the latitude would be positive. This is how the consideration would be done for latitude and departure in different quadrants, looking at their bearing. These negative positive values of latitude and departure can automatically calculated if you are using the bearings in whole circle bearing system. But if you are using the quadrantal bearing system, then in that case you need to consider the signs for latitude and departure for different quadrants. Now let's solve an example related to this. In this example, we have been given with a line, AB line, which is part of a traverse that has a length as 20 meter and bearing given in WCB system as 70 degree. We have been given with the coordinates of point A as 100, but the coordinate of point B is to be calculated. We know the standard direction. Now drawing the sketch for AB line that has the length 20 meter and the bearing as 70 degree. Since we are being asked to calculate the coordinates of the forward point, the coordinate of the backward point, point A is given. For that we need to calculate the latitude and departure of the line. So this horizontal distance would be the departure, the orthographic projection on east-west axis, and the orthographic projection of the line on north-south axis would be the latitude of the line. Since we already derived the formula for the departure and latitude, the formula for the departure is L sin theta and formula for the latitude is L cos theta, where L is the length of the line and theta is bearing. Both are given to us. So we can then calculate the departure of the line as well as the latitude of the line, and when we do the calculation, the departure will come out to be 18.8 and latitude as 6.84. Since from our previous discussion I already discussed that the departure will be added with the first value, which is 100 here. So 18.8 would be added with 100, and also the 6.84 will be added with the 100, which is again the same value. So 100 plus 18.8, 100 plus 6.84. When you do the calculation, the coordinate of point B will come out as 118.8 and 16.84. So with the first digit that usually shows the horizontal distance, so in that we need to add the departure value. The second digit, which usually shows us the vertical distance, so latitude is to be added in that. So this is how the calculation would be done when the coordinate of one point is given and coordinate of the next point is being asked. Also the length and bearing of the line is also given to us. So this is all from this video. Thank you for watching the video.